Good morning children and welcome back to your chemistry class. So we were dealing with this chapter of alcohols, phenols and ethers in which we were doing phenols. We have already studied about phenols, their classification and the nomenclature, and also how are they prepared, their physical properties as well. So today we shall talk about its chemical properties. So to begin with the chemical properties, the first property of it that we are going to study will be the acidic character. Okay, the acidic character of the phenols. So how can we judge the acidic character of any compound? It can be treated with the alkali metal or its hydroxide, and then it has to release salt and hydrogen if in case of metal, and water in case of its hydroxide. Clear? So if this happens, then we can say that this particular compound is acidic in nature. So let us see to this, that if I take phenol, that is C6H5OH, 2 molecules of it, and treat it with sodium, that is the alkali metal. And let's see, do we get the salt? Yes, we do get the salt over here. So this is your phenol, which is acidic in nature because it gives you the salt and hydrogen gas. Similarly, this phenol, when treated with the hydroxide of an alkali metal, which is basic in nature, isn't it? This is basic in nature. So acid, when combines with a base, what it should form? A salt and water. So here it is forming the salt and water. Clear? So this acidic character of phenol, it is mainly due to what? Due to the presence of this OH group and the resonance stabilization of the phenoxide ion. So now I will explain you this acidic character more in detail, talking about its resonance stabilization of that phenoxide ion. Clear? So this acidic nature of phenols, it is actually attributed to plus M effect, or what we say plus mesomeric effect of your OH group. Clear? Now what is this plus M effect of OH group or mesomeric group is what I am going to explain you over here. Try to understand. What happens over here? That the lone pair of the electron on oxygen, it enters into the delocalization with the benzene ring, right? And thereby what happens? It makes oxygen develop a positive charge over it. Now this positive charge on oxygen, it reduces its hold over this hydrogen of the OH group. Followed? And this weakening of this OH bond and the removal of hydrogen as a proton to form either the gas hydrogen or to form water molecule, this explains the acidic character of phenols. So here you are going to see the resonance structure, how I can explain you the plus M effect or the plus mesomeric effect of this hydroxyl group, right? So look over here carefully. This is your phenol, OH, right? This comes here. Then now see here, plus mesomeric means the lone pair is going to enter into the delocalization with the benzene ring, and then what happens? The oxygen attains a positive charge over itself. This oxygen, it is going to attain a positive charge over itself. And this was minus, and now what? This comes here, so a double bond will be formed here. Let me draw this. This is OH plus. Now from here negative ion will be formed because this bond is broken, and comes here, and lastly so this explains the plus mesomeric effect of this OH group. What did I explain you over here? That the lone pair of this oxygen, right, it enters into delocalization with the benzene ring, and what happens to the oxygen? It attains a positive charge over here, and due to this, what happens? It reduces its hold over the hydrogen of the OH group, and thus this causes the weakening of the OH group, and the removal of hydrogen as proton takes place over here. So this explains the acidic character of phenols. Next, let us talk about the second point, that is reaction of phenols with zinc dust. Okay, so it gives benzene on heating with zinc dust. So let's see this phenol. When it is treated with zinc dust on heating, what did I say? It gives us benzene ring plus ZnO, right? Then next, third reaction, if we talk about reaction with PCl5, right? The replacement of the OH group of this phenol by a halogen atom, it is very difficult, and thus it yields a chlorobenzene, which is very poor in yield. So this is your phenol. When treated with PCl5, it is going to give a very minor product of your chlorobenzene, right? This is your minor product, plus POCl3 plus HCl will be formed here, right? Next, now let us look at the fourth reaction, that is reaction of phenol with acid chlorides and acid anhydrides. Okay, so over here phenol, that is C6H5OH, when it is treated with acid chloride or acid anhydride, it always forms esters. Okay, so let us treat it with ethynyl chloride, that is C. Let us treat it with ethanoyl chloride, that is C2H5COCl. As I told you, it is going to form ester, that is C6H5OCOC2H5. This is called as your ethionate. Okay, it is called as phenyl ethionate. Then C6H5OH, that is phenol, when it is treated with benzoyl chloride, that is C6H5COCl. What is this? This is called as your benzoyl chloride. What was this? This was your ethonyl chloride. Okay, so this process takes place in the presence of NaOH, that is sodium hydroxide, and this is also going to form an ester called as phenyl benzoate, C6H5O, C6H5, right? This process, that is when phenol, it reacts with benzoyl chloride, then this reaction is also termed as benzoylation. What is this called as? Benzoylation. And this reaction is also termed as Schotten-Baumann. Can you see? No. Schotten-Baumann reaction. Okay. So what is benzoylation or Schotten-Baumann reaction? When a phenol is treated with benzoyl chloride in the presence of NaOH, what is it going to form? It is forming phenyl benzoate. This reaction is called as benzoylation, and this reaction is also termed as Schotten-Baumann reaction. Clear? Now I will give you another reaction like C6H5OH. Let us talk about acid anhydride. So it can be CH3O whole twice in the presence of CH3COONA. So here again it is going to give you ester, that is CH3COO C6H5 plus acetic acid will be given out, right? So this reaction I forgot to tell you, this is called as acilation. Okay, that is in the presence of NaOH, phenol with the ethanol chloride when treated in the presence of NaOH will give you phenyl ethionate, the ester, and this reaction is called as acilation. When phenol is treated with benzoyl chloride in the presence of NaOH, the reaction is termed as benzoylation. It is also called as Schotten-Baumann reaction, right? And when this phenol is treated with acid anhydride, then it forms again an ester and acetic acid is formed here, right? Now we shall study about some electrophilic substitution reactions. Electrophilic So let us begin with some electrophilic reactions. The hydroxyl group present in the phenol is an ortho or para-directing group, right? Therefore, these phenols, they undergo this electrophilic reactions, right? And what are those electrophilic reactions that we have to study over here? Like for example, halogenation, nitration, sulfonation, bromination, and so on, right? So let's begin with the first electrophilic reaction, that is bromination. Okay, so over here the phenol, it reacts with bromine to give 2,4,6-tribromophenol. Okay, what does it give? I repeat when I draw over here. What did I say? 2, 4 and 6. So this OH remains here. 3 bromine atoms are there. So which places did I say? 2, 4, 6. Okay. So the name becomes 2,4,6-tribromophenol, right? Plus 3 HBr will be released. And the color of this 2,4,6-tribromophenol, it is a white PPT. Now let's talk about nitration. Right? Phenol, when treated with concentrated HNO3. Okay, this is your concentrated HNO3, 3 molecules of it, in the presence of concentrated H2SO4. It is going to give you picric acid. Now what is picric acid? Once again, let me draw this. Once again, let me draw the structure OH, and now 2,4,6-trinitrophenol is actually your picric acid. So what did I say? 2,4,6. This is 2,4,6-trinitrophenol, which is also called as picric acid, right? Plus, what does it give? 3 molecules of water. But with dilute HNO3, it only gives the ortho and the para products. But with concentrated HNO3, it is going to give you at 2, 4 and 6 trinitrophenol. Next, let us talk about then the third one is the sulfonation. Okay, over here phenol, when treated with concentrated H2SO4 at 373 Kelvin, then it is going to give you a major product, that is paraphenol sulfonic acid, right? But that same phenol, when it is treated with the concentrated sulfuric acid at 293 Kelvin, then its major product is and what is this called as? Orthophenol sulfonic acid. So these two are the major products formed at the particular temperatures. Okay, they are the major products. I hope this is very clear to you. Some more reactions, 1 or 2 more reactions left. Let me teach you that also. Now let us understand some other reactions of phenols also. Some important reactions of phenols, right? So the first one that we need to know over here is carboxylation of phenol. Okay, carboxylation of phenols, which is also called as Kolbe's reaction. Also called as Kolbe's reaction. So over here, the phenol, it is treated with sodium hydroxide. Okay, what happens? Water is removed, forms salt, when treated with carbon dioxide at 400 Kelvin with 6 to 7 atmosphere. Here rearrangement takes place, forming your sodium salicylate. Okay, so what is the formula of sodium salicylate? OHCOONA. What is this? This is sodium salicylate, right? And this, when it is treated with an acid in the presence of water, it forms salicylic acid. What is this called as? Salicylic acid. This is termed as Kolbe's reaction, also termed as carboxylation of phenols. What happens over here? That phenols, when treated with sodium hydroxide, they form salt, which further, when treated with carbon dioxide at 400 Kelvin and 6 to 7 atmosphere, is going to form sodium salicylate, where rearrangement takes place. Treated with the acid in the presence of water will form salicylic acid. Okay. Then the next important reaction is your Rimmer-Tiemann reaction. Rimmer-Tiemann reaction. Note these reactions, they are very important. Over here, the phenol, when treated with chloroform in the presence of NaOH, which is aqueous in state, at 340 Kelvin, that is ONaCHO plus ONaCHO. This in the presence of any acid, right? It forms what is this? This is your ortho-hydroxybenzaldehyde as para-hydroxybenzaldehyde. Clear? So Rimmer-Tiemann reaction is clear to you. Now, the reaction of phenol can also take place with carbon tetrachloride even in the presence of aqueous NaOH, right? To give a mixture of what? Then ortho-hydroxybenzoic acid will be given and para-hydroxybenzoic acid will be given. This is also your Rimmer-Tiemann reaction. So, what did I say over here? The product you are going to form, I am just giving you a start over here. What did I say? That phenol, when treated with carbon tetrachloride, also in the presence of an aqueous NaOH at 340 Kelvin, what is it going to give you? It will give you ortho-hydroxybenzoic acid, right? And para-hydroxybenzoic acid. So with chloroform, it gives you benzaldehyde, and with the carbon tetrachloride, it is going to give us benzoic acids. Clear? Next, the third one is your coupling reaction. This is your coupling reaction. It gives bright colored Azo dyes. Okay, so over here the diazonium salt, it reacts with phenol. So let me draw a diazonium salt over here. This one reacts with phenol. What is it going to give? This is your diazonium salt, okay? And this is your phenol, right? When they combine in the presence of alkaline medium, what did I say? It gives us Azo dyes. What is the formula of Azo dye? So what are they called as? These are called as Azo dyes. These Azo dyes are of bright color. Bright color could be like, they could be red color, or they are yellow, or even found in orange color. Plus HCl is given out. What is the name, the IUPAC name of it? It is 4-hydroxy-azobenzene. Clear? The last reaction to mention over here is your Friedel-Crafts reaction. This I have already shown you, but there I forgot to mention this name, Friedel-Crafts reaction. So under important reactions I am mentioning this. So phenols, they undergo this Friedel-Crafts reaction when in the presence of acetyl chloride in the presence of anhydrous aluminium chloride. Okay, in the presence of CH3COCl. This is the reaction I had told you. What is this? This is your acetyl chloride when treated in the presence of anhydrous AlCl3. What it is going to form? It will form a minor product, that is right, and a major product. So this is the minor product and this is your major product. Okay, now what is the name of this minor product? This is your ortho-acetyl phenol, and the major product is your para-acetyl phenol. Okay, lastly we come to the tests for phenols. Okay, so the first test is when the aqueous solution of phenol, it gives a violet coloration with a drop of FeCl3. What is that product formed? That is a water soluble complex. Okay, the water soluble complex is formed. What is that called as? Look at the formula, FeOC6H53 minus. This is the complex formed, which is of the violet coloration. Okay, and the second one was your Azo dye reaction, right, where the coupling reaction had taken place. That is another test for the phenols. Alcohols, they do not show Azo dyes. alcohols they do not show, whereas the phenols they give the coloration with the azo dye, right? So lastly we come to uses of phenols. Where are these phenols used? Firstly, they are used in the perfumes, in the perfumery industry, okay? And secondly, it is widely used in the manufacture of your dyes and plastics. In manufacture of dyes, plastics, etc. So with this we finish off with the phenols also, right? Next chemistry period we shall begin with ethers. Thank you.